Okay, so with that problem, we've worked on how to come up with a decimal number based on binary. Now we're going to kind of work that the opposite direction. This question is, again, question number one, but this is found on the 2020 test, Invitational 1. Most likely, you know that the 2020 uh, tests, there were only Invitational 1 and 2, or A and B, because due to COVID, everything was shut down, so the other tests were never released. So in this case, we're going to kind of go the opposite direction. Instead of having all of our numbers written out, we are going to, well, instead of having the digits, rather, and knowing what the binary number is, we're going to have to go through and figure out what the decimal number is. So, again, they have the answer here for us so that we have a chance to look at it. Here is a quick little table. Here's one. This is the two. This is the 4, 8, 16, 32, 64, 128, and 253. The next, if we kept going on this table, the next one we would go to would be 256. And 256 is too big to be subtracted from 253. So we don't need that one. That's why we're not going that high. But actually, I could have just erased it. 253 minus 128, because that's our biggest number that we can use. Now, just subtract like normal. Change that to a 4. 13 minus 8 is going to give us 8, 9, 10, 11, 12, 13. So that's going to give us 5. 4 minus 2 is going to give us 2. And then 2 minus 1 is going to give us 1. So we have 128. Now, problem is 125 does not go into 128 because our 253 rather does not go into 256. So now we're going to have to subtract 64 from this number. 5 minus 4 is 1. We have to borrow from the 1. 12 minus 6 is 6, leaving us with the 64 here. And we're left over with 61. Now we're going to subtract 32. So again, we're going to have to borrow. It makes 11, so this will be 9. On this side, we end up with 5, 29. So we have 132. And the next number we're going to be looking for is 29. 29, the next biggest number that can go into 29 is 16. So we will have a 16. 9 minus 6 is 3. 2 minus 1 is 1. So we have 13. Well, 13 minus 8. So we're going to have an 8. 13 minus 8, we discovered a few moments ago, is 5. 5 has a 4 in it, or can subtract a 4. So 5 minus 4 is 1. Now, at this point, we have a big decision to make. Because in the 2's place, 5 minus 4 is a 1. And so we have no way to put a 2 in here. So if this was something like a 6 right here, 6 minus 4 would be 2, we could do it. If it was 7, 7 minus 4 would be 2, or actually be 3, but you would have a 2 and a 1 both available, so everything would be 1s. And if you look at the answers, A, everything are 1s. B, right now, everything up until the last 2 are 1s. And so every single one that they have, except for E, has 1s all the way up to the last 2. E, however, obviously we can mark off because that one is a 0. When we hit here, though, 4, we got the 4, but 2 cannot go into a 1 or cannot be subtracted from 1. So we're going to have to put a 0 in the 2 spot. So that means C is out, and that means A is out. Now, at this point, we can take the 1 out, and that leaves us with a 0 at the end, so there's a 1 there. And the answer then has to be B, which their answer also showed us B. Okay, so that is taking a look at going from decimal to binary.